Hello students, my name is Hala Yunus. I am an academic and higher degree researcher at the School of Computing, Engineering and Mathematical Sciences at La Trobe University. My research area is structural engineering. In this video, I will brief you about the strain gauges applications in my research project. But before that, I would like to give you a brief about my research background and the problem. Generally speaking, engineered wood products provide good sustainable solutions as an alternative to hardwood products, especially in mid and high-rise buildings. However, engineers, architects, and designers find it challenging to design long and heavy loaded structural beams with a 300 millimeter deep and span of 5 or 6 meter is not typically achievable as it exceeds limit requirement for deflection limits. Also, it is not acceptable for architectural purposes. As a result, the timber framing option in these buildings was replaced with steel members or replaced with a not local expensive timber structural members as seen in this picture. My research is focused on strengthening a local timber structural members using an optimal strengthening ratio of carbon fiber reinforcement polymer to improve the mechanical properties of LVL and expand its use and applications to large-scale buildings. So in order to understand the behavior of the timber composite beam, so we need to measure the deflection and we need to measure the strain and stress at these weak points. This is the structural beam, this is the carbon fiber reinforcement polymer sheet, and this is the reinforcement techniques that used in this research project. And here is the application of the adhesive, and the last step is attaching the carbon fiber reinforcement polymer and develop a timber composite beam. Now, in order to measure the strain as I said, at the tension region and the compression region, we use this strain gauge product. So this is the strain gauge. Gauge is a product that used in this research project. From the strain gauges, we will measure the strain, we'll measure the deformation, we'll measure the stress and other parameters. And this image shows the unpacking, one of the unpacking strain gauge. And this is the strain gauge properties. This is the strain direction grid. This is the length, this is the width, and this is the properties. Now, in order to apply the strain gauges to the beam, these steps were followed, starting with preparing the beam, then sanding the area that we need to attach the strain gauges to it. So we use this sandpaper. The next step, we need to do some cleaning and remove the dust generated from the sanding process. And we will use one of the solvent cleaning product, as you can see here. Then the next step, we need to determine exactly the location of the strain gauges, where we need exactly to put them. So as explained before, one will be attached to the tension region and one will be attached to the compression region in order to measure the strain at the mid-span tension region, and the other one will be at the mid-span compression region at the top here. After determining the location, now we need to apply the adhesive, and different type of adhesive used depends on the type of the surface. So for the carbon fiber reinforcement polymer surface, this type of adhesive will be used, and for the timber, for the timber surface, this type of adhesive was used. The next step was testing the accuracy and checking if the strain gauges is working or not. So we need to use this small device and give us the correct reading. So if it's correct, if it's according to what is written in the guideline, then we can use it. If it's not, then we should not use it, because it will not give us a good or accurate result. And this is the final step. Attach the strain gauges at the tension and compression region. And after this step, we need to leave the strain gauges attached to the beam for at least 24 hours to make sure the adhesive were dried very well and ready to do the experiment. So this is an example of result obtained from the experiment at the tension region, and this is the stress estimated using this formula, model of elasticity times the strain. Thank you, and hope you enjoyed this video.